Yesterday, we rolled the bowling ball across the classroom, and 0-0. What was the next person? 1. Next person? 2.2. Next person? 3.4. Next person? 4.3. Next person? 5.5. Next person? 6.4. We'll say there. Okay. So those are the points. And then what we're going to do is do a best fit line. Little shaky. We'll go with it. All right. So, math people. Slope is equal to what? Rise over run. Change in y over change in x. y2 minus y1 over x2 minus x1. Oops. Correct? Okay. So I'm going to pick 2 points. So when you do a best fit line, the practice on that is don't pick points that you plotted, but pick points along the line. Granted, another good practice would be use a straight edge to draw the line, but we're going to go with it. Okay, so I see a point here. That's a nice convenient. And I see a point we'll say here. Pick those 2 points. Okay, so I've got 4.2 over 4 seconds minus 0.6 over 0.6 seconds. Good with that? Okay. So we have 3.6 meters over, well, that's interesting, 3.4 seconds. Equals 1.06. What's the unit on that? Meters per second. What does that number communicate? Like, what is the significance of that number? Like, what does that tell us, Gillian? We just did something mathy to figure out something in real life, how fast the bowling ball is rolling. What? Okay, I know, right? So is that about right? Like the bowling ball is moving 1 meter a second? It's like, yeah, right, about this one, every 1 Mississippi. Yeah, crazy. Okay, so check this out. So y2 minus y1, we were doing final position over final clock reading minus initial position over initial clock reading. What is this quantity? Change in x, displacement over this. What's this quantity? Change in clock reading, time interval. Hey, we've seen this before. Crazy. Okay. So the takeaway is the slope of a position versus time graph tells you your velocity. Good with that? Here's an even bigger picture. This is true for any and every graph that you come across the rest of your life. Okay. The slope is rise over run. Okay. If you want to figure out if the slope communicates anything, look at the units on the x and the y axis. Here on the y axis, this is position. It's measured in meters. Okay. On the x axis, it's measured in seconds. So rise over run, meters over seconds. Is that unit something that communicates stuff? In this case, yes. It's meters per second. Oh, that's like how fast it's going. Sometimes the slope of a graph will tell you stuff, other times it won't, but you can look at it, you can figure that out by looking at the units. It's a really good hint or trick the rest of your life. Okay. Thumbs up when you have a guess. Have a conversation. Correct answer is A. At this moment in time, you're located here. Okay. This does not tell you about displacement. Displacement is the change in position. So displacement would be this. Good with that? Okay. Thumbs up when you have a guess. Have a conversation. Tell them why you think so. Correct answer is A, purple. Why? Has the steepest slope. The rate of change of position is the fastest. Okay. Talk to your neighbor. Correct answer is? Correct answer is B. Sometimes on conceptual questions like this, it's helpful to make up numbers. For this one, like if we put ourselves on the football field, 10, 20, 30, 40. Where are they all racing to? To the 0. The green started at the 20, the blue started at the 30, purple started at the 40. Does that make sense? Do not influence or be influenced by anybody else. You'll have a chance to converse momentarily. Thumbs up when you have a guess. Tell them what you think and why you think it. All right. This one usually invokes a good conversation. Okay. let me just throw this out at you. If you find yourself missing questions or a question that you missed, do not kick yourself. Realize you just learned something. And that's a great thing to write down. Like, capture the moment. Like, oh, this is okay. Correct answer is A, purple. But the blue one's longer. True. But we're looking for displacement. The blue went from the 30 to the 0. The purple went from the 40 to the 0. The length of the line does not communicate displacement. Good with that? Keep it in your head. Don't converse. Resist the temptation to verbally process. You can do not influence or be influenced. Communication takes a lot of different forms. Have a conversation. Tell them why you think so. Correct answer is dangerous dinosaurs. Okay. 5 seconds, 10 seconds, 15, 20, somewhere, I don't know. Green ends at 10 seconds, purple 13, blue 17. Good with that? Okay, this dotted line is just a reference point. Thumbs up when you have a guess. Do not converse until you are released to do so. You may do so. Tell them why you think so. Correct answer is? Correct answer is A, orange. Here's the storyline. Ready? Blue and orange swap places on the football field. Orange goes from the 0 to here, where the blue started. Blue went from here to 0. Orange just did it in less time. Good with that? It traveled the same distance. Orange just did it faster. Good? Next question. Talk to your neighbor. Correct answer is? C. Correct answer is C. Okay. This first part, is it a positive or negative slope? Positives. Is it steep or shallow? It's a steep slope. So that corresponds with fast or slow? Fast. So you have a positive, you're going fast in the positive direction. Is this a positive or negative slope? Positive. Steep or shallow? Shallow. So you're going fast or slow? Slow. Okay. So you're going here, going slow in the positive direction. Good with that? This is a warm up. Something like this. Do not converse until you are do so. Thumbs up when you have a guess. Have a conversation. Correct answer is? Okay, correct answer is A. Here's my recommendation for things that curve. Take it in chunks. What do I mean by that? There's a chunk. Approximate the slope in that chunk. Is that a positive or negative slope? Negative. Is it steep or shallow? Shallow. So that means fast or slow? Slow. So you're moving slow in the negative direction. And look at that chunk. Approximate the slope there. Positive or negative? Negative. Steep or shallow? Steep. So is that fast or slow? Fast. So put it together. You start slow in the negative direction and speed up in the negative direction. Good with that? Thumbs up if you got something. Compare notes.
I thought I was going to go off on like just one more theory, but
Is it possible to find this stuff?
the answer's
The average or the instantaneous? Both. Average is easy. It's just x1 over, like, it's just, you just pick 2 points. That would be the average.
But what about instantaneous?
Calculus. All right, correct answer is? Correct answer is E. Educated elephants. Okay. So here, steep positive. So it's going fast in the positive, shallow positive. So slow in the positive. So you start fast, slow down, moving in the positive direction. Good? Have conversation.
Yeah. I think it's B. Well, B abrupt. Hey. Right on the swing.
Oh, yeah, yeah. Well, I don't want time travel.
It's not smart in physics class.
Just do the hardest or the
Okay, what do you say? Oh, we've got some learning to happen. Here we go. Take it in chunks. Positive or negative? Fast or slow? Positive or negative? Fast or slow? Positive or negative? Fast or slow? Somehow we went from slow negative to slow positive. What has to happen right somewhere in here? You stop and turn around. Does that make sense? It has to be a turnaround point. And then finally, positive or negative? Fast or slow? So put it all together. You start fast in the negative direction, slow down, stop, turn around, speed up in the positive direction. D. Dangerous dinosaurs. Nope, sorry. Scratch that. E. Oh, I was right. D. Dangerous dinosaurs. My bad. Good with that? Okay. Thumbs up when you have a guess. Tell your neighbor what you think. What do you say? Correct answer is D. Dangerous dinosaurs. Slow, negative, fast, negative, slow, negative. Good? Okay. Changing gears. We're now looking at velocity versus time graph. Okay. So my recommendation would be think what your speedometer reads when you're interpreting these graphs. Okay. Okay, that point on a velocity versus time graph. Thumbs up when you have a guess. For the sake of time, I'm going to tell you. Correct answer is only B. You know what your speedometer says, but you have no idea where you're parked. Okay? You could be at the 0-yard marker, but you could be anywhere on the football field at 0 meters a second. You okay with that? It's important to know what a graph tells you, but also what it doesn't tell you. Okay? It's going to tell you this velocity versus time graph tells you how fast you're going in which direction, but does not tell you where you're located, your position. Okay? Hang on. We're out here before or after. I'm going to use every moment of it. Thumbs up when you have a guess. Okay, before I tell you the answer, I'm going to take you through this analogy. You're on the entrance ramp getting onto I-65. At some point, your speedometer passes by 40 miles an hour. Does that mean you've traveled 40 miles? No. What that means is you are at that moment in time moving at a rate that you would travel 40 miles if you maintained that rate for an entire hour. Does that make sense? The distinction there, okay? What this point tells you is you are traveling at 2 meters a second. You have not necessarily traveled 2 meters unless you have traveled at 2 meters a second for an entire 3 Mississippi, for an entire second time interval. This, you would have traveled 2 meters for the entire second. But this point just tells you the rate at which you're moving at that moment in time.
Good morning, teachers and students.
Good with that?
Pardon the interruption. This is Mr. Myers with a quick reminder about student parking. Reminder this morning is that your student parking pass applications are due this Friday, 8/23. There are paper applications in the main office, and those applications have also been emailed to the junior and senior class. Parking enforcement will begin next week. As a reminder, all students are to park in the east, south, and north lot only, and not in the west staff parking lot. This includes work-based learning and GLCA students. Again, you are not to park in the west parking lot. No students in the west parking lot. Once again, your parking pass applications are due by Friday. The cost is $27. The application is in the main office. You've also been emailed the application, and I will send that application to you via email before the end of the day today. As a reminder for those students who exit the east side of the building and travel out to County Road 600 North, when I am waving you northbound onto the road behind the football stadium, it is important that you do not cut that turn too short, as sometimes there are vehicles traveling north and turning right into the science cafeteria parking lot. So be very careful as you're turning left. I'm waving you on to the north to head out towards 600 North. Do not cut that turn short when I'm waving you on. Again, student parking applications due Friday, 8/23, $27, paper applications in the main office. Thanks. Go Raiders.
Talk to your neighbor. Got one more slide after this. Okay, for the sake of time, I apologize. I was C. Okay, make up numbers. 0, -1 meters a second, -2 meters a second. You're moving at a constant pace in the negative direction. Okay, last slide. This is just a general overarching. Here's how you read a velocity versus time graph. you're going above the x-axis, you're moving in the positive direction. Okay? Below the x-axis, you're moving in the negative direction. Okay? Ah, boogers. Positive 1 meter per second, positive 2 meters a second, positive 3 meters a second. As you're moving this way, you're getting faster. Most people do not have a problem with that. I'll tell you what people have a problem with tomorrow.
Or mostly in the morning.
What's that?
Oh, sorry, you're recording. Forgot about that.
It's all right. As you go away from the x-axis, you get faster. So going this way and that way, you get faster.
I think it'd be better if we had a patrol car. Like have Officer Morgan down at that intersection over there.